So have you heard of Galasa before, Julia?
No, this is the first time. I was interested because me and my colleague presented something about testing yesterday as well. So,
Okay, cool. So um, what Galasa is it's a deep integration test framework which has native understanding of both COS and hybrid multi-cloud platforms. So as we look at applications which are running both on Z and utilizing the Z platform, but also having elements of them running on both on-premise, public, and other cloud platforms, we see the need to actually do a level of integration testing across that whole platform. And to do that, you obviously need to integrate with a whole range, not just different platforms, but different middleware, different test products. And that is what Galasa is. It's an integration test framework, not just integrating together tools and platforms, but also allowing you to run integration tests across these hybrid cloud applications. And it's constructed very much with scalability in mind to serve enterprise requirements. It's not just about running the tests, it's about giving you the tools to report on those tests, giving you the tools to catalog the tests that you've got, to understand the content of those tests, and to manage your test corpus. And it is an open source implementation of the same test framework that we've been using in Kix, DB2 and ZOS for over the past 10 years. So we constructed something that was primarily for use for testing Kix. But of course, you can't really test Kix without having MQ, DB2, IMS, VSAM, a whole realm of other middleware products integrated with Kix as well. So we soon had to build capabilities in that tool for all those other platforms. And then our testers started coming to us and saying, well, we want to use this tool, we want to use JMeter, we want to use this test tool, test tool, we need to use WSIM to generate load. But we started building capability into the test framework to provide those users with the tools that they needed. And then we started seeing customers come to us and say, well, you do DevOps in Kix, how do you do automated test? And we showed them what our tool did, and then decided that actually with a few pivots and a few tweaks, we could actually refocus it from something that would test Kix and Kix applications to actually testing our customers' Kix applications across the hybrid cloud platform. So we're going to start off with a demo, because if pictures speak louder than words, then actions speak louder than pictures. And I only do pictures because I'm not that brainy. That's why I've got James who's going to do the actions, which are going to be better than the pictures. So what we want to show is exactly what I've just been talking about. I want to show you Galasa testing a hybrid cloud application. And this hybrid cloud application consists of a Kix application sat on ZOS. It's accessing a database, and it's exposing a set of services. In this case, we're talking SOA-based XML services to a cloud-hosted web server that's running the web UI. Now, that web UI is then interacted with by a web browser, which is going to fill out some forms on the web UI as part of the web server, which in turn is then going to update the Kix application, our system of record, with those updates. And that's what we want to test, that entire piece, that entire application. And I want to be able to do that testing both from an IDE such as Eclipse, but also as part of my CI/CD pipeline being called from Jenkins. So let's have a look at that test in a little bit more detail. If we disregard the preparing of the environment and the discard of the environment, and actually just look at what we actually want to do in the test itself. Well, the first thing we need to do, we need to provision an account number. Well, to provision an account number, we'll need to run some JCL to actually run a batch program that will create us some test data. And then we want to use Selenium to drive our web UI at the opposite end of the stack to connect to our provisioned web application, fill in a form, and basically do a transfer of funds from one account to another. And once we've hit go on that button, we want to check that we get a good response come back. And then to ensure that that data update is actually persisted into our system of record, we want to go through a set of 3270 screens to use perhaps an older access mechanism into the system of record to validate that the account exists it's got the expected balance, and the transfer has taken place. So that's the test, and you can kind of see that that's what you would do if you were writing this down as a test script for someone to manually follow. But because we're doing this in automation, we want this to be run in an automated way, there's a set of steps that we'll have to do in order to kind of provide that environment to do the testing in. So let's have a look. We've said we've got two environments. We've got a cloud provisioned environment, and we've got a ZOS LPAR running a Kix application. So let's take the cloud piece of the puzzle first. I've got a web browser, and I've got a web UI. I've got a web server. Now, this part of my application is probably going to exist as a container, and it's going to exist. That container image is going to exist in a artifact repository somewhere, maybe a local copy of Docker Hub or something similar. And I need to provision that within a Kubernetes style cluster. Well, Galasa can do that. We can provision that cloud image in a K8s cluster and get it ready to be tested against. What about my Kix application? Well, that's going to sit in a ZOS LPAR. Now, that may have been provisioned for us as part of our CI/CD pipeline. We may have had UCD involved, perhaps creating the load libraries and new copying the programs. It may have been a virtual, perhaps an IBM ZD&T image that has been provisioned and brought up just for this test. Either way, Galasa needs to bind those two environments together and bind both of them to the test, because obviously in our test, we don't want to hard code any details. Say, here's where the web UI is, here's where the Kix app is, here's the Apple ID, here's how you can run a Jez job over there. It should need to know all of that detail. It just needs to know that when the framework starts and gives control to the test, it will have provisioned all of that environment and bound the test to that environment. The test is then going to use the framework's API to drive that batch job to create the customer account. It's then going to run a set of Selenium tests against the provisioned web browser to drive the web UI functionality and check that we can perform this transfer of money from one account to another. And then finally, it's going to go through a sequence of 3270 screens to drive the Kix application to ensure that the system of record has been correctly updated. So that's the test we want to do. It's a golden path test. It's not destructive. It's not error path testing. It's none of that. It's just a simple golden path test to show you what can be achieved with the Galasa test. But don't let the slides and the pretty pictures prove it. Let's show you exactly what this looks like. So James, I don't know if I need to stop screen sharing. Or
I believe I can just take it. So let me know when you can see my screen.
Yeah, we're there, mate.
Cool. So a couple of things on screen right now. I've got an Eclipse session, which is showing a Java test. And at the bottom, you've got a terminal here, which I've just told it to repeat the docker ps command. So as Will was just showing in some of the diagrams a second ago, we can talk to a Kubernetes cluster to provision cloud portions of our application. For this demo, so I can actually show you these moving pieces coming up quite quickly, I thought I would just point it at my Docker engine running on my laptop, so we can see the containers coming up as we run this test. All from that just bottom terminal screen we can see there. So if we have a quick look at this piece of Java, which is our Galasa test, you'll notice there's groups of annotations at the top of the test. And I've very roughly split them with a comment saying there's some application specific objects. So these are objects that are going to be passed to our tester, which have some meaning in terms of the application under test. So the web app annotation at the bottom here is the embodiment of our Docker container, which contains our web server, which we'll be interacting with via a web browser. But as Will also said, we are going to be running some batch jobs. We're going to be connecting up to a real 3270 screens. So we need some ZOS interactions here as well. So I've asked the Galasa framework via these annotations, I need you to give me a ZOS image which has the tag SimBank, so we know that the sim application is running on that image, so we can use it within our test. And then we have some Selenium ones and some bundle resources and a logging and reporting kind of style annotation. But if we actually have a look at the test, which if we read the amount of lines of code here, it's not very many, because most of this is comments. Admittedly, there is several utility methods which are doing pieces of work which we can have a quick look at in a second. But this test is going to provision me an account number. It's going to go check that it doesn't exist on our LPAR already and in our application already. And it's going to do this using some 3270 screens. And if it doesn't exist, it's going to open it. We're then going to set up a few parameters which we're going to use as part of the test. So this is how much are we going to credit an account by? And we do that here, and we set it up, and we just said this is going to be the random number of money that I'm going to send to an account. And we've got a quick method here which will complete the web form on our web application and click submit. The last few lines of our code here are essentially just validation. So one, we check to see if the page came back as a 200 response. You have successfully completed your transaction. And the second set of asserts are all to do with that 3270 validation. We're going to log into our Kix application and validate that the piece of data that we got provisioned has not only been provisioned properly, but also updated as part of the test. So if we want to have a look at how this looks in our utility method, so this is a Selenium method that is completing the web form and hitting submit. We just get an object passed to us from the Galasa framework, which just embodies the page that we're interacting with. So I can say, send that account number to the field, which is the account number, and hit enter, take screenshots. So we can do all this very simply, as you'd probably expect any Selenium test to look in Java. Here we have some 3270 interactions. So we can see bank terminal. So this is the terminal that we're going to be interacting with our banking application. We can push PF1, we wait for the keyboard, we position the cursor to the field containing account number, we hit tab, we type the account number, and so on. These very simplistic kind of keyboard actions are also still very simplistic to perform in Galasa. So rather than just reading through every line of code here, because it's not a huge piece of code, but it's not the most interesting to read through, why don't we just submit it and see what happens? So if I come back and just hit run on this, I'm going to try and quickly talk through it, but hopefully we should see a Docker container appear at the bottom, but we can, there you go. So there's our web app being provisioned. We saw some 3270 screens. There was a piece of JCL that's just flown by. We're waiting a response. This red writing at the bottom, this is all the Selenium responses we're getting. So I've asked it to run headlessly so we don't get screens popping up here and there, and it passed. That's it. I think it takes about 13 to 14 seconds to run all those stages, including the binding, the provisioning, the test logic, and the validation. So that's all nice seeing it run on the command line through the console here. But what happens if this was running in automation and running from a Jenkins pipeline or some other means of submitting this test, and it's failed? We need to be able to see all the test results and the test artifacts. So if I just load up our test run here, we can see it passed, and we can see, but it's not the interesting bit. We can see the full run log, which I'm not going to scroll through because we've just seen, but we also have access to all the stored artifacts. So I spoke about Selenium. We can see all the screenshots. This is the web application as we were filling it out. So our randomly provisioned account number, our randomly provisioned amount that we're going to credit onto our account, and we can just see all the way every step that our test took. But in the same location, so I'm not going to have to go hunting for this. I can then go see all the terminal screens that my ZOS LPAR saw. So I can see us logging on. I can see us going to our banking application in Kix, typing in transactions, loading up accounts and things like this. And we can say account not found. That was what it was checking for. And same for the batch jobs. We can see the full spooled output. So we've got the JES JCL, JES message log, JES sys log, and we've even got the sys out of our application itself. So in one single location, we have access to the test itself, the run log, and all the run artifacts that go alongside this. So I've just run this all in Eclipse. This is not the only way that we can do this. And I'm going to pass you back now to Will, who's going to take you through some of the other ways we can run tests in Galasa.
Thank you, James. So let's just share that screen. And before we carry on, I think it would be good just to, Sarah has joined us, so we now have two people. I'm going to ask Sarah to unmute. Did anyone have any questions about what they've just seen?
No, it's all clear, thank you.
Yeah.
Okay, cool. usually we don't get to ask those types of questions. So yes, so where James left you is he'd taken a test of this application and shown you that it can be run locally from his own machine. So that test was running on his local laptop, but it was connecting to a Kubernetes cluster that we have provisioned, and it was also connecting to a z/OS machine to run the mainframe application. And we call that a proof of concept stage. So in a proof of concept, we support local runs running from someone's laptop and calling out to mainframe resources or cloud resources as and when they need to in order to invoke the test. And this kind of process is very, very lightweight, very easy to instantiate, very easy to get going. And your local JVM is spun up for each test that you want to run, and that hosts the entire Galasa framework. Now, obviously, that's a great solution to get started. It's not a great solution as you want to move towards running these tests in full automation. So there's kind of a stepped process. The first one being local. So here we've stand up the Galasa ecosystem. We'll talk about what that ecosystem is. But what that ecosystem is going to allow you to do is to start to share configuration. So this is good when you have multiple people trying to run a set of tests. So it means that everyone can share the same configuration. Everyone can share the same set of mainframe resources or LPARs that they're using to run their tests. And this is really useful when you're developing new tests, because you can understand that you only have to do the configuration once. But when we run a test, that test is still running locally on the developer's own machine. The next stage is to start to use more of the capabilities of the ecosystem that you stood up on the previous step. So now you'll be able to use an IDE to actually ask the ecosystem to run a Galasa test on your behalf. Now, when you do this, you don't need to have all the source code locally for that test. In fact, the source code could be compiled and sat in an artifact repository elsewhere, and the ecosystem will pull the right test from the artifact repository and start to execute it. It also allows you to benefit from test catalogs. So as you build a test, you can annotate the test to say this test tests this particular area of my product, or it's a BVT test that I always want to run. And then you can use that meta information to select the right set of tests that you want the ecosystem to run on your behalf. And when the test runs, we create a Docker container for each test that's running that's got its own JVM. So we've got perfect test isolation running within the Galasa ecosystem. And finally, the final evolution of this line of thought is automation, where you've no longer got a human sat at a desk using some sort of IDE to invoke tests in the automation. It's being run through as part of a CI/CD pipeline. And the Galasa ecosystem provides a very simple REST endpoint to allow any CI/CD pipeline orchestration product to integrate and to invoke tests in the Galasa ecosystem. We supply a Jenkins plugin that really simplifies this operation, but in case you're using something similar we don't give you great support for at the moment, it should always be possible by invoking that simple REST endpoint. And tests running in our full automated Galasa ecosystem are truly scalable. Because we're creating a new pod, a new Docker container, each time we want to run a test, this thing can horizontally scale as much as you've got capacity for. We use it internally to run our own tests against Kix and other parts of the IBM z/OS stack. And when it comes to crunch times of the product release, we're really pushing the amount of tests that we can push through the Galasa ecosystem. In fact, usually the sticking point or the bottleneck is how many CPs we've got available on the mainframes that we're looking at, or where our tests are running, not the horsepower of our Kubernetes platform. So this is really powerful because it is providing you enterprise class integration testing as an open source project. So we talked a little bit about the Galasa ecosystem and the value that provides, but what is that Galasa ecosystem? So the Galasa ecosystem is just really a set of microservices delivered as a service within a on-premise cloud offering. So it is a sequence of microservices that allow IDEs, pipeline products to call into the ecosystem and say, can you run some tests for me? How are those tests running? Have they passed? Have they failed? have you finished running them yet? It also allows a pipeline to do the same. It allows them to submit a batch of tests and then get a pass or fail result back. So this is where the Galasa approach differs from some other frameworks you may have worked with, because this is test as a service. So we're not providing you with something that you run inside your framework or something that runs inside of a build environment or a build worker. It runs as a service separate from those resources, and you make requests to that service to run tests, to check the results of the test that you've run. And it's the Galasa ecosystem that is providing that piece of capability. So let's pop the hood, which works nice in the UK, but when I present this in America, pop the hood sometimes doesn't go down quite as well. And have a look at what actually the Galasa ecosystem contains. So like I said, it's a set of microservices. We've got the CPS, DSS, RAS, API server, resource manager, and the engine controller. So we're going to quickly just go through these and explain why they're important and what they do. We're not going to go into a lot of depth in all of them, but we're just going to give you a brief idea. So the CPS is our configuration property store. And at a high level, it just holds all the configuration that is going to be shared across all of the Galasa test runs. So when a Galasa test needs to know, well, I've been told to run on this cluster as part of the test, where is that cluster? Can I get access to that cluster? It will use the CPS to get that information, which means you've got no hard coding in any of your tests. And that's really, really important, because as you move from maybe using pre-provisioned ZOS LPARs today to maybe using virtual machines in the next few years, you don't want to have to rewrite all your tests. And the CPS abstracts all that away, allowing a test to run on any ZOS platform. The second service in there is the DSS, the Dynamic Status Store. And the DSS holds all the information about all the tests that are currently running. So this means that the entire ecosystem knows exactly what's running at any point in time. It knows all the tests, it knows what tests are running and what resources they are using. This allows us to be smart. If you tell us that on a certain ZOS LPAR, there are only 3 slots that you can run tests on, and you try and run 4 tests in that environment, we know that we can only run 3. So the first 3 will get dispatched, the 4th will be told to wait. And it will just sit in the Galasa ecosystem pending. And as soon as one of those slots becomes free, we'll allocate the 4th test. So this means you don't have to worry about bombarding the ecosystem with tons of tests thinking, oh, half of them might fail because they can't access Z. No, the Galasa ecosystem, when properly configured, can protect you from that and queue the tests appropriately. The next is the result archive store. So we said that one of the benefits of running your tests in an automated fashion is that all the results from all the aspects of the test will be held in one central location. And that one central location is the results archive store. This means when a test fails at 3 a.m. in the morning, when you're doing a big test run, the first person that gets in can easily get access to the data to start doing diagnostics. It means, like, for example, today, I had a colleague talk to me and say, I had a test fail. Could you possibly help and debug why that's happening? Sure. All I needed was their unique run ID, and I could enter that into my IDE and instantly get the run editor screen that James showed you with all the details of that test. I didn't need them to export anything to me or send me a zip file over Slack. I just needed the ID, and I can see the same test data that they're using. Our API server is the piece of the puzzle that really glues all these things together. It's the API server that shows or gives the API to the outside world, and is the thing that will be prodded when someone wants to run a set of tests. Finally, Resource Manager. So Resource Manager really is the key piece of the puzzle for allowing this to run for a long amount of time and creating a stable platform in which to run tests. Because even as a tester myself, you can't trust testers. Testers will tend to do some rather nasty things to a test platform. It's kind of their job. So you never know when a tester might do something really bizarre in a test and forget to clean something up. Well, that's fine. Galasa knows all of the resources that every test is using and can clean them up. So for example, if let's say you need a certain port number as part of your test, well, Galasa can provision you a port number. And then let's say that test dies. Perhaps you do something really silly like division by 0. Then Galasa can understand that that test engine has suddenly died, disappeared out of nowhere, but it was related to that port number and can free it up on that test behalf just before it's been cleaned. So this means that you don't have multiple tests reusing resources that haven't been properly cleaned and returned to a pool to be used. This really helps to ensure that when you run a set of tests, they run cleanly and they run well. And finally, at the heart of Galasa is the engine controller. And this service is responsible for instantiating individual test engines. As I said, each time we run a test in Galasa, we'll spin up a new Docker container that contains the Galasa framework. So he's the guy that's responsible for saying, can this test run? Does the DSS tell me I've got enough slots available for where it's going to run? Yep, I do. Great, I'll spin up a test engine to run that one test. And once the test engine has been spun up, that test engine can interact through all of our extensibility managers to touch any part of the system under test, be it MQ, DB2, Selenium, Docker, the list is endless. It can interact with all those resources, a public cloud provider, private on-prem cloud provider, or ZOS with native understanding in a safe, structured, isolated way. We touched upon this a little bit just before about why do you need a test framework? Why have we gone to the expense of creating this whole framework and an ecosystem to run it in? And it comes down to four real main points. First is that it allows you to have a consolidation and an integration of varied test technologies and tests all in one place. I've worked with customers and I've said, okay, what does your testing look like now? And they say, oh, it's all automated. It's great. It's all automated. Okay, cool. What tests are you going to run for this piece of work that's just been delivered? Well, we'll need to do some manual testing. Okay, so we'll ask this guy to run those tests. Okay, great. And now we'll do some web UI testing, and that involves Selenium. So we'll go and get the person that knows how to run the Selenium test to run those tests. And basically, all their test work was fragmented by different groups that had different capabilities and experiences. Galasa allows all of those experiences to be, sorry, just someone entering the room. It allows all of those things to be integrated into one test result group. So it allows you to consolidate all of those test technologies into one place. When you need to look at the output, they're in one place. Secondly, the test framework and the Galasa ecosystem allows you to have testing as a service. Anyone in the environment can ask for tests to be run against any level of the code. And because that is being run as a service, which is separate from your build pipeline, you're not slowing up your build pipeline or having to install lots of stuff into your build pipeline. It's a separate call to a separate cloud provision service to run those tests. Second is a question that we actually had at Share. I think it was late last year. Oh, can't I do all this with Zoe? Can I do all this with some scripting technology? Could I use Mocha to do some of this? And the answer, tactically, in the short term, probably some of it. There are tools out there that allow you to interact with kicks, and you copy a program and do little bits like that, but they don't tend to give you all of the enterprise things that you'll also need. Scripts are good, but as they grow in number, they become harder to manage. How many scripts have I got? Have I run them all? Where are the results for them? Where's the output? Where do they run? When you have a test framework that's managing all of this for you, then those problems go away. I know how many tests I've got because I can just check against the test catalog. Have they all run? Well, I can see from this dashboard. Yes, they've all run, and here are the results. So it gives you that peace of mind that these aren't just now separate pieces of work. They're all consolidated and integrated together. And when you need to answer that question of, are we ready to ship? We've also given you a set of dashboarding capability and resulting capability to show you where the problems are and what results have run. And what's more important is that all of this is being shared as an open source project. It's not a licensed product by IBM. It's open source. It's being developed and promoted entirely in the open. So what's new? What's new in the latest versions of Galasa? Well, this is quite a big one. So when we first started writing Galasa, because it was built from JAT, all of our tests had to be Java classes. And we got some feedback that although a lot of customers felt that Java was a good language to use, they didn't feel that not everyone in their department necessarily had enough Java skills to be able to write a Galasa test. Now, our API really does allow and prevent or protect the programmer from having to learn an awful lot of Java. You definitely don't need to be, a certified Java programmer to understand how to write a Galasa test. Our API allows you to do things like run batch jobs, interact with the 3270 terminal in a really easy way. But we wanted to go one step further. So what we've actually done now is we've baked the ability into the heart of Galasa to allow it to be a polyglot test automation framework, which basically means it can understand multiple languages to implement a test case. And the first one that we've created support for is Gherkin. So many of you may know Gherkin as a language that's used within the Cucumber framework for doing BDD or TDD style testing. And it gives you quite a nice English syntax in which to describe your test. So what we've done is we've added support into the heart of Galasa to support multiple languages. And then we've taken our 3270 manager that handles all of our interactions with the 3270 screen. And we've enabled that to understand Gherkin step definitions. So it means if you look at the test on the left-hand side of that screen, where we are saying, I'm given that I've got a terminal, wait for this string to appear on any terminal field. Now wait for the keyboard to be freed. Now move the cursor to a particular field and press tab. And now type a username, and now type a password, and now press enter. So it allows you to actually write your tests in Gherkin and run them inside the Galasa framework. And this test on the left-hand side can be run in Galasa with literally no extra lines of Java code required. Now, at the moment, it's just for 3270 screens. But in the future, we'll be adding the step def capability to other managers where it makes sense to allow us to maybe run batch jobs through Gherkin. And we believe that this is a real step forward in allowing more people who aren't necessarily Java programmers to write Galasa tests in a way that they feel is quite easy and understandable. We talked about the 3270 manager there as being enabled for Gherkin support. Well, what managers have we supported? Well, the list on the left-hand side in bold are all the managers that we've currently released as part of the open source project. And on the right, we have a set of planned managers. And you can see that this slide in itself is already a little bit out of date, because on the right-hand side, we've got the CEMT and CEDA managers as being planned, ready to go. Actually, they're probably going to be in the next release. They're in the later stages of testing now. They're pretty much ready to go. So they'll be moved over to the left-hand side. So this is kind of just showing that since we started, we had our first kind of real public release back in January. We've released all of these managers. We're going to be releasing the ecosystem support, and we are still a growing and lively project. So what ZOS managers have we added? So I mentioned just about CEMT and CEDA, but I'd like to add in there the Keki manager and the RSE API support. So the Keki manager was the direct result of a customer's request. They wanted to be able to run a Kix application within a Galasa test, not by invoking the 3270 BMS maps, just by constructing some data in a container on a channel and just throwing it at a program and looking at the response. And we gave them the Keki manager that allows them to do just that. It's also really useful if you want to do some error testing by perhaps manipulating the contents of a TS queue before you run a test. Really helpful. Our RSE API support. This has been a long time coming because basically it was a large piece of work. But whenever you interact with whenever you interact with running a command on a ZOS LPAR or running some JCL, at the moment, up until this point, you would be doing that through ZOSMF. Now, we were aware that that was fine if customers were running on a proper full LPAR running on Z hardware, but if they were running inside a ZD&T image, maybe that had some performance implications. So what we've done is we've provided a new back-end implementation for our ZOS JCL batch and command managers, allowing them to also use RSE. Now, RSE is the same backend that you would use if you connect IBM Developer for System Z up to your mainframe, and it's using that same API that they provide. So this runs really great on provisioned ZD&T images. It also runs great on real ZOS LPARs running on proper IBM Z hardware. So regardless of how you need to connect to your mainframe, the actual API that we present to the test, that doesn't change. So you can actually switch between the two. And this is really valuable. If you're going to be running some Galasa tests as part of your pipeline, maybe you would spin up a ZD&T image to run that test. And then maybe as you get closer and closer to production, you're now wanting to run the same set of tests, but on pre-production real hardware. We can switch between the RSE implementation and the ZOSMF implementation completely seamlessly to the test, which allows you to do both without changing any test code. Deployment options. How do you deploy Galasa into the field? Well, we've already released a Docker operator, and I'm really proud to say that we've also now released the Kubernetes operator. So the Docker operator gives you a simple command that you can run that will bring up all the microservices that compose the Galasa ecosystem in a single command. This is really helpful, gives you a really quick way of standing up an ecosystem that you can use with Galasa. But the Kubernetes operator, oh, that's even better, because what the Kubernetes operator can do is actually monitor your workload. And if it sees that a pod has fallen over, it can go and restart it. Hey, sometimes in our environment, we will see a pod fall over because maybe a node has gone down, but our operator will come along, restart it. Often we don't even notice. So this means that our test platform is reliable, it's robust, and it's ready for running in the enterprise. We'll also shortly be releasing a web-based UI for ecosystem management. So what does this mean? Well, at the moment, to manage the ecosystem, you've primarily got to do it through the IDE. That's how you'll be running tests. That's how you'll be getting the run log back. But we're producing a web-based UI, and we've done a ton of work in designing this to make it as easy to use as possible. So that means from a web browser, you'll be able to look at tests, run tests, and also review their output. So this means that if you've got a test, as James showed you earlier, which is interacting with Selenium, JCL, 3270, containers, all of that information can be viewed from a web browser. And like I said, we're doing all of this in open source. There's no secret package that we're holding back and saying, nah, that's ours. That's the magic that makes it work, and we're gonna charge you. It's all available, freely available as an open source project. Our Galasa GitHub repository is under the organization Galasa-dev. We've also got our website galasa.dev, where we show all of the information and promote all of the new releases. So how do you get started? How do you start working with Galasa today? Well, you can start off in an assess stage, and we provide you with something called Galasa SymBank. Galasa SymBank is vitally important. If you're going to be running integration tests, then you need code to test. So what Galasa SymBank does is it provides you with a simulated ZOS application called Galasa SymBank, which you can run on your local workstation. We also provide you a set of Galasa tests that test that instance of Galasa SymBank. This means you can run tests, you can create new tests, you can augment the tests that we ship, all without touching a real mainframe. Hey, you could do it from home, where I guess most of us are anyway. But it means you can try it, you can pull it from our open source repositories, and you can get started. Those of you who are parents, get the kids involved, give them some training on what it means to be an enterprise tester, show them what you do during the day. Then you can then explore Galasa. Once you've worked out how a Galasa test looks, how it feels, you can now bind it to a real environment. So bind it to one of your mainframes and start using some of our managers to interact with that environment. So obviously this is going to be a test or a test environment to begin with, but it allows you to start understanding how Galasa might bind to your system. Secondly, also thirdly, you'll then bring up an ecosystem. So this will then involve maybe getting hold of some access to a Kubernetes cluster, or you could run it on your own machine. Not ideal, but definitely possible. And then you can use that information or that shared environment to share the configuration with other testers, get more people involved, get them to understand how a Galasa test works and how it applies to your environment. And then finally, automate. Start bringing up tests that are going to provide value to you, and then you can use them in a real environment. And what's really nice is, even though we only started this publicly in January, we already have some customers that are pretty much now in that final stage where they've got tests that they are running that prove valuable things about their environment. So that's really good that we've seen customers start to not just assess these things and try them out, but now start to get real value for their enterprise applications. So how can you get involved? Well, we would love contributions. Now, that doesn't have to be a pull request on our Git repository, although that would be amazing. Just having conversations with us about your experience, what you've tried, what worked, what didn't, what can we help you with, help us to make improvements. You can get involved with calls and speak to us about what you'd like to see in the next iteration so we can work with you and sculpt the future of Galasa. And to do that, we've got 3 mechanisms that you can get involved with us on. The first is our Slack channel. So we've set up an open Slack workspace that anyone can join. And in there, you've got the IBM developers, you've got customers from around the world who are all trialing out Galasa at the moment. You can ask questions, and you can do that in an open forum, or if you want something more private, just call out to one of us and we can arrange a private channel to have that conversation. All of the information about Galasa is available on galasa.dev, which is our website, where you'll find what's in the latest release, find documentation, and eventually find some hints and tips for how to make the best use of Galasa. And finally, all of our code is available in the Galasa-dev repository in GitHub. So I'm going to pause there. We're just a little bit ahead of time. People we start, and if there are questions, if you could post them.
Will, you are
in
lag.
Slack.
You have
in the
quite
Zoom
a lot of lag
chat.
in your chat right now.
Was that a,
So
Okay.
I was going to say,
premonition to him dropping off? Dropping off.
yeah. So if there's any questions, just pop them into the chat box, and hopefully I can answer some of them if Will returns. So I think Will's back now.
Hi, can you hear me?
Yeah, we can hear you.
Okay, yeah. So if
At least it waited till the end.
Well, you know, good timing, right? I think it was just someone trying to say it's time for you to go, sir. If you've got any questions, if you'd like, in fact, you know what? We've got only a few people. I can ask people to unmute, and if you have a question, I've asked you to unmute. You can unmute yourselves now, and you'll be able to ask a question.
Will, could you see Galasa coming on to master the mainframe at all?
I don't see why not.
Okay.
Absolutely, considering there's a whole wealth of mainframe tools in there. Yeah, absolutely. There's no I'm sorry.
And he's gone again.
Well, no, I think he's just about to have a coughing fit or something. But,
Sorry, something hit the back of my throat and I couldn't talk. Yes, there's no reason why it couldn't be involved in master the mainframe.
It's, you know, it just strikes me that we Joe kicked off GSE on the app dev stream saying that since Zoe's been part of master the mainframe, the number of downloads has gone ballistic. And it does seem to be an excellent way to introduce people. You know, I'm pretty excited, even though, you know, at CompuWare we have testing frameworks. You know, I think it's a pretty interesting open source initiative to bring stuff. I'd like to understand a little bit more about the stuff that James showed. You know, I don't know if there's an opportunity on the meetups to cover this a little bit more, but it's incredible how an open source initiative can get across to the next gen of engineer or early career engineer, you know, and that's what we want on the platform, isn't it?
And I think what's really important about this is really the SimBank starter, because it allows you to if we didn't have that could be run locally on your system and wasn't a full-fledged version of Galasa, there'd always be a problem that, oh, well, to get going, I need to get something installed on the mainframe. And I'm really against that. I really need this to be able to someone, like I said, when I kind of talked about SimBank, if you've got kids, they've got a laptop, get them to install Galasa, get them to play with it, because there's no harm. That's why we've made it available. So you can, on your personal laptop, just get going, understand what it is. And then when you're making that case to say, we probably could do with trying this in our environment, then you've got a good understanding of what it does in the first place. You can show an example on a laptop which is disconnected from the network. So it's really powerful to be able to get the technology into people's hands with a really low barrier to entry.
I have a question as well, sorry. So just to check that I've understood correctly, the original source code of the application that is being tested is not required to be uploaded in the environment itself. Galasa can link to it, can connect to whatever server or other environment that it's running on.
That's absolutely correct, yeah.
Okay.
There's a question in the chat from Sarah. Is there any ready-to-try sandbox system available to try Galasa? So the best we have for you at the moment is our Galasa SimBank and SimBank example, which is, although it's not a sandbox, so it's not like Z-Trial, which you may have used in to try Kix things. It is something that you can download onto any laptop. Obviously, the owner's laptop, allowing those, some people have quite restrictive things that they can do. But it exists as an Eclipse plugin, and you can just download it, and everything you need is then local on that machine, ready for you to run.
Yeah, and the great thing is Galasa itself doesn't actually know it's not talking to a real system. So it's not as if any of the interactions are going to change from using the SimBank application to an application running on ZOS.
Yeah, but if something like a Z-Trial or something a little bit more provisioned would be useful, which you could perhaps try through a browser, then please let us know, join our Slack channel, have that conversation with us, because if that's something we hear from other people, then it's something that we can definitely investigate. We are as I said, we are testing as a service, so deploying the test as a service shouldn't be too difficult for them people to get hold of. Another one from Julia. Can any test script be run on Galasa or other testing tools? So this is our integration point, in that we originally started off with Java, but we then added the capability to run Gherkin tests. Now, we can integrate with pretty much any testing tool that you need us to integrate with. So we support things, at the moment, we support things like JMeter, Selenium. So you can use that test tool to integrate with or as part of a Galasa test. So if you've got any particular tool that you'd like to see an integration point with, then that's something that we can definitely investigate. But it's that kind of metric is if you have, so we are doing work with virtual test platform, WASI virtual test platform, to see how we could integrate with them to provide cross-cutting capabilities between the two tools. So if there's a particular tool that people are using that they'd like to see integration with Galasa, then yeah, please raise an issue on GitHub, speak to us about it on Slack, and we can add it into a release plan.
Yep. And if you are like particularly impatient, or there's something that is in-house to you that we can't do for you, all the mechanisms of how to write these integration points will be available on galasa.dev at some point. I believe the documentation is being developed for it right now. So you can start designing and building your own managers, which will just fit into the Galasa framework. So you can extend Galasa as well as what we offer.
And that's the nice bit, because of the license that Galasa is offered under, it allows you to take the source code, it allows you to develop a component of Galasa and then do what you want with that component. That component can be licensed however you wish. So It means that you can take a component, you can write a new component that integrates with Galasa. You can contribute that back to us. That would be brilliant. Or you can take it, you can license it, you can offer it under a different license. So it's quite. I think it's so we release under the Eclipse Public License version 2, which is a very permissive license to basically say you can do what you'd like with this code. Okay, I think that's the end of the questions.
Yep, I believe we're coming up to the hour anyway, so that's good timing.
Yeah,
brilliant.
Excellent session. So 28X was the meeting feedback for Sarah and Julia, please. And great session. Really appreciate your time, gents, and looking forward to hearing more and seeing more about Galasa in the near term.
Cool. Well, cheers, guys. Thanks very much.
Thank
Very much,
you.
everyone.
Cheers. Bye-bye.
Bye.